Dear students, today we will see some problems on vector that is based on collinear vectors, coplanar vectors, how to find position vector of a point and its magnitude, or the how to find unit vector along the direction of given vector. We will also see some problems on that. Let's see one by one. Now see the first problem. State the vectors which are equal in magnitude, parallel in the same direction, equal, negative of one another. Here some vectors are given and we have to find out which vectors of these are equal, which vectors are parallel, which are in the same direction, which are equal vectors and which are negative vectors of one another. Okay, let's see first problem. First we will find equal in magnitude. Now observe these vectors. Which vectors are equal in magnitude? See here A bar, then C bar, and this E bar. A bar, C bar, E bar. These three are equal in magnitude. They have asked you only magnitude, not the direction. Therefore, you see only magnitude. This A bar, C bar, and E bar are equal in magnitude. Again, which pair is equal? See here B bar and D bar. Again, B bar and D bar have same magnitude. Okay, therefore write down the answer of first A bar, C bar, E bar, and B bar and D bar are equal in magnitude. Means these three vectors A bar, C bar, E bar are equal in magnitude. Again, there is another pair B bar and D bar which have equal magnitude. Then let's see which vectors are parallel. Here, see A bar, B bar, this C bar and D bar. These four vectors are parallel to each other. Direction is not important. They are along the same direction or opposite direction. Only see they are parallel or not. See here A, B, C, D. These four vectors are parallel to each other. Therefore, write the answer of second. A bar, B bar, C bar and D bar are parallel vectors. Then what is third? In the same direction. Means we have to find only vectors which have same direction. See here A bar, B bar, these two vectors have same direction. Then C bar and D bar, these two have same direction. Okay, and this E bar have different direction. Therefore, this will be not the answer. Now, what will be the answer? Your third. A bar and B bar have same direction. A bar and B bar have same direction. Again, C bar and D bar have same direction. Then we have to find in the fourth question equal vectors. Which vectors are equal here? For equal vectors, their magnitude should be same and direction also same. See here A bar, C bar, E bar have equal magnitude, but all the threes does not have same direction. Okay, if we compare A and C, then they have equal magnitude, but direction is not same. Therefore, they are not equal vectors. Again, C pair B bar and D bar, they have same magnitude, but direction is not same. Therefore, they are not equal. Means all of these five vectors, none of the vector are equal vectors. Okay. Therefore, you write down none are equal. Then question is negative of one another. Which vector negative of one another means what? See in our first lecture of vector, we have seen definitions of equal vector, parallel vector, negative vectors. Okay. Now negative vector means what? They should have same magnitude, but direction is opposite. See here A bar and C bar, they have same magnitude, but opposite direction. Therefore, they are negative vectors of each other. Again, B bar and D bar, they have same magnitude, but their direction is opposite. One pair is A bar and C bar of negative vectors that is having same magnitude, opposite direction. Here again, the second pair B bar and D bar have same magnitude but opposite direction. Therefore, these pairs are negative vectors of one another. In this way, if definition is clear in your mind, you are able to find the answer of such questions, and such questions will be asked in the exam for 2 marks. Okay, let's see the second. Now in the diagram here, KL is given A bar, means position vector of this vector KL is A bar, then LN is B bar, NM is C bar, and KT is D bar. This is given. And we have to find in terms of A bar, B bar, C bar, D bar, these vectors. That is vector LT, Km, Tn and Mt. We have to find these vectors in terms of A bar, B bar, C bar and D bar. Okay. See here, consider this triangle KTL. Using triangle law of addition, this KL plus LT can be written as KT. Using triangle law of addition, this KT can be written as KL plus LT. Then keep the value of KL, A bar and value of KT, D bar in this equation. We will get A bar plus LT bar is equal to D bar. In the next step, you transfer this A bar to the right hand side. We will get LT bar is equal to D bar minus A bar. And first we have find out. Okay. Now, using polygonal law of addition of vectors for the polygon, see here K, L, N, M for this polygon, K, L, N, M. We will use polygonal law of addition. Now, this Km can be written as KL plus Ln plus Nm. Go according to direction of arrow. This Km can be written as KL plus Ln plus Nm. Okay. Then keep the value of KL A bar, Ln B bar and Nm C bar, and we will get value of Km bar is equal to A bar plus B bar plus C bar. Only we have to put the values of that vector. Okay. Then see next. Again using polygonal law of addition to the polygon. See the polygon here. T, K, L and N for this polygon. T, K, L, N. We will use again polygonal law of addition. Here this Tn, this Tn can be written as Tk plus Kl plus Ln. This Tn can be written as, see the diagram carefully, this Tn can be written as Tk plus Kl plus Ln. Then keep the value of, see here, Kt is d bar. Here Kt is d bar, means direction of vector is from K to T, and we are writing here Tk, means we are going from the point T to K, means we are going in opposite direction. Therefore, this vector will be minus d bar, means this Kt and Tk are negative vectors. They have same magnitude but direction opposite. They are negative vectors of each other. Therefore, if Kt is d bar, then Tk will be minus d bar. Okay. Then keep the value of Kl, A bar, Ln, B bar, and we will get Tn bar is equal to minus d bar plus A bar plus B bar. Okay. If you don't like this negative term at the first place, you can rearrange the equation A bar plus B bar minus D bar, or if you keep this as it is, then that is also correct. Now, again using polygonal law of addition of vectors for the polygon. See the polygon T, K, L, N, M for this polygon. T, K, L, N, M. Now, what will be this Mt? This Mt bar will be, this Mt bar can be written as Mn plus Nl plus Lk plus Kt. This Mt bar can be written as, means here we are going from M to T. This is initial point, this is terminal point. Okay, or this is head and this is tail point of the this vector Mt bar. Now we have to reach from point M to T. Then another method is how to reach at point T. See here, Mn bar, Nl bar, Lk bar, Kt bar. Okay, in this way, and keep the value of here Mn. Here Nm is C bar, therefore Mn will be minus C bar. Then again we are going opposite to the direction of vector. Therefore, if Ln is B bar, then Nm will be minus B bar. Therefore, we are writing here minus C bar minus B bar. Again, this Lk will be minus A bar because Kl is A bar. Therefore, Lk will be minus A bar. If you are going according to direction of that vector, you write that position vector as it is. But if you are going opposite to direction of that vector, then you change the sign of position vector. Here we are going in the same direction as that vector. Therefore, this will be as it is. Kt bar will be d bar. In this way, we have find empty bar is equal to minus C bar minus B bar minus A bar plus D bar. In such type of problems, you remember that if you are going according to direction of that vector, then you write down that position vector as it is. But if we are going opposite to that direction of vector, then we have to change the sign of position vector. Okay. Then see the next problem. Find the magnitude of following vectors. Here some vectors are given and we have to find their magnitude. Here first is A bar is equal to I minus 2j plus 4k. B bar is equal to 4i minus 3j minus 7k. Means here position vectors of two vectors are given. And in the third problem, a vector with initial point 1 minus 3 4 and terminal point 1 0 minus 1. Here initial point and terminal point is given, means we have to first find that vector in terms of its position vector and then we have to find its magnitude. Okay, let's see one by one. Here, what is mean by magnitude of vector? In our previous lecture of vector, we have seen how to find the position vector of point, and if we have found position vector, then how to find its magnitude. Okay, now here coefficients of ijk are called components of that vector. Okay, here coefficient of I is 1, coefficient of j is minus 2 and coefficient of k is 4. These 1, minus 2, 4 are called components of that vector. That is components of ijk. If component of I is x, component of j is y and component of k is z, then magnitude of a bar is under root x square plus y square plus z square. We have seen that in our formula in our previous lecture. We will use that formula. Here you write down mod of a bar. Magnitude is written always in the mod. Therefore mod of a bar, or you can write down simply a, is equal to in the square root. Here component of I is 1. Write down 1 square minus 2 square plus 4 square. In the square root you write down components of ijk, its square and addition. That is 1 square minus 2 square plus 4 square. And this will be equal to, in the square root, 1 plus 4 plus 16, that is equal to root 21. In this way, it is very simple. You just see the components of ijk, take their squares, their addition in the square root, you will get magnitude of that vector. Okay, then see the next. Here mod of b bar. Here coefficients or components of ijk are 4 minus 3, 7. Therefore, you write down in the square root 4 square minus 3 square minus 7 square. This will be equal to in the square root 16 plus 9 plus 49, and addition of that will be in the square root 74. Okay. Now in the third problem, initial and terminal point of the vector is given. Let the initial point will be a 1 minus 3 4 and terminal point be b 1 0 minus 1. Then find the vector a b bar. For that you consider a bar be the position vector of this point a and b bar the position vector of point b. A bar will be I minus 3j plus 4k and b bar will be I plus 0j minus k. Then AB bar means B bar minus A bar. First you write down position vector of terminal point, then minus position vector of initial point. AB bar will be B bar minus A bar. And you keep the value of B bar and A bar. Simplify that. See here, I minus I will be 0i, 0j, minus of minus means plus 3j, and minus k minus 4k means 5k. In this way we got AB bar is equal to 0i plus 3j minus 5k, or you can simply write down 3j minus 5k. Okay, then what will be magnitude of AB bar? Here components of ijk are 0, 3 minus 5. Therefore you write down in the square root 0 square plus 3 square plus minus 5 square. And after simplification, this will be in the square root 0 plus 9 plus 25, that is equal to root 34. Okay. Then see the next example. Here A is 2, 3, B is minus 1, 5, C is minus 1, 1, and D is minus 7, 5 are 4 points in the Cartesian plane. Then find AB bar and CD bar. Check if AB bar and CD bar are parallel to each other. Then third is E is point having coordinates K1 and AC is parallel to B. Then we have to find K. Okay. Now here point A, B, C, D are given. Let A bar, B bar, C bar and D bar be the position vectors of given points. Therefore, A bar will be 2i plus 3j, B bar will be minus I plus 5j, and C bar will be minus I plus j, and D bar will be minus 7i plus 5j. Then we will find AB. This AB bar means B bar minus A bar. Keep the value of B bar, A bar. Simplify this. Minus I minus 2I means this is minus 3I. 5j minus 3j will be plus 2j. Means AB bar will be minus 3I plus 2j. Then we will find CD bar. For CD bar, you write down position vector of D bar minus position vector of C bar. Okay. CD bar is equal to D bar minus C bar. That is equal to, keep the value of D bar and C bar, simplify this. Minus 7i minus minus, this will be plus. Minus 7 plus I means minus 6i. And this will be 5j minus j means plus 4j. Therefore, CD bar will be minus 6i plus 4j. Okay. See here, write down CD bar. CD bar is what? CD bar is minus 6i plus 4j. Just we have find out it in our first problem. Then 2 common, then in the bracket that remains minus 3i plus 2j. And what is this minus 3i plus 2j? That is nothing but our AB bar. Therefore, you write down this 2 times AB bar. Now CD bar is 2 times AB bar, means one vector is scalar multiple of other. Therefore, these vectors are collinear, means parallel to each other. Collinear vectors means, what is the definition of collinear vector? If vectors are collinear, they are along the same line or parallel to each other. Okay. Then we will find BE bar. For BE bar, write down E bar minus B bar. That is position vector of terminal point minus position vector of initial point. Keep the value of E bar. Here, point E is K1. Therefore, its position vector will be Ki plus j minus B bar. That is minus I plus 5j. Now open the bracket, simplify, take the terms of I together and take I common from that, and we will get K plus 1 times I minus 4j. Okay. Then AC bar will be C bar minus A bar. Keep the value of C bar, A bar, open the bracket, and we will get, after simplification, AC bar is equal to minus 3I minus 2j. Now what is given? Here it is given that B and AC are parallel vectors. B and AC are parallel vectors. If two vectors are parallel, then one vector is scalar multiple of either. Okay. If two vectors are parallel, then there exists scalar such that, non-zero scalar such that one vector can be expressed as scalar multiple of other. Suppose there exists scalar m, non-zero scalar m, such that BE bar can be written as m times AC bar. Then you keep the value of BE bar and AC bar. Compare these two vectors. Here open the bracket. This will be minus 3mi minus 2mj. Now these two vectors are equal vectors. These two vectors are equal vectors. When they are equal, if their coefficients of ij are equal, that is components of ij are equal, then and then only these vectors are equal. Here coefficient of or component of I is k plus 1, and here component of I is minus 3m. Equate these two. Here component of j is minus 4, and here component of j is minus 2m after opening the bracket. Okay. Now here we are comparing components of I and j, and we got two equations here. Now solve these two equations. From this equation second, we will get the value of m2. Simplify this. Divide this equation throughout by minus 2. We will get value of m2. Now keep that value of m in this equation. We will keep value of m in this equation. In the next step, you transfer this 1 to this side. We will get k is equal to minus 1 minus 3m. In the next step, you keep the value of m2. That will be k is equal to minus 1 minus 6, that is k is equal to minus 7. Okay students, I hope it is clear to you. Let's see the next. Determine the values of C that satisfy mod of cu bar is equal to 3, u bar is equal to I plus 2j plus 3k. Okay. Here vector u bar is I plus 2j plus 3k. Then what will be Cu bar? Cu bar will be, you multiply both sides by C. Cu bar will be ci plus 2cj plus 3ck. Then what will be mod of cu bar? Mod of cu bar means in the square root you take here components of ijk are c, 2c, 3c. Therefore, in the square root you write down c square plus 2c square plus 3c square. Simplify this. After simplification, this will be in the square root to the right hand side, in the square root c square plus 4c square plus 9c square. And value of mod of cu is given here 3. You keep that to the right hand side. Now take the addition of these vectors, then this will be equal to 3 is equal to in the square root 14c square. Then take this c square outside the square root, that will be simply c. Therefore 3 is equal to in the square root 14c. Okay, in this way we have got c is equal to plus minus 3 by root 14. Here we are taking square root of this c square, and square root of this c square must be plus or minus c. Therefore we are writing here plus or minus sign. Okay, therefore c is equal to plus or minus 3 divided by under root 14. Okay, see the next problem. Find the unit vector in the direction of u bar and in the opposite direction of u bar, where u bar is 8i plus 3j minus k. Here we have to find unit vector in the direction of u bar. Now again we have seen in our first lecture of vector definition of unit vector. Unit vector means what? If you have to find unit vector in the direction of any vector, then that unit vector is equal to that vector divided by its magnitude. Okay, just simplify this. Here u bar is 8i plus 3j minus k. Then find its magnitude. Mod of u bar is equal to in the square root. Here components of ijk are 8, 3 minus 1. Therefore write down in the square root 8 square plus 3 square minus 1 square. Then this will be equal to in the square root 64 plus 9 plus 1. Square of 8 is 64, square of 3 is 9, and square of minus 1 is 1. And this will be equal to in the square root 74. Then unit vector is always written by cap. Therefore you write down u cap. That is equal to u bar divided by its magnitude. Here we have to find unit vector in the direction of u bar. Therefore write down u cap. This cap denotes for unit vectors. This shows that this u is unit vector. Therefore write down u cap is equal to u bar divided by magnitude of u bar. Then value of u bar is what? 8i plus 3j minus k. You keep that here, and magnitude of u bar is root 74. In this way, this is the unit vector in the direction of u bar. Now in the second, you have to find unit vector in the opposite direction of u bar. See, if you have to find unit vector in the opposite direction of u bar, means only sign of this vector will get changed. This vector is positive, means unit vector in the opposite direction of u bar will be only having negative sign here. Therefore you simply write down here minus u cap. First here write down u cap is equal to 1 upon root 74 times 8i plus 3j minus k is unit vector in the direction of u bar. Then we have to find unit vector in the opposite direction of u bar. Only change the sign of vector here. Write down minus u cap will be the vector in the opposite direction of u cap. Therefore this will be equal to minus 1 upon root 74 times 8i plus 3j minus k is the unit vector in the opposite direction of u bar. If you have find out unit vector, only change the sign of that vector, you get the vector opposite in the direction of u bar. Okay, see the next. Show that the vectors 2i minus 3j plus 4k and minus 4i plus 6j minus 8k are parallel. Here we have to show these two vectors are parallel, means we have to show one vector is scalar multiple of other. Write down these two vectors. Write down a bar is equal to, or suppose first vector a bar and second vector b bar. Therefore write down a bar is equal to 2i minus 3j plus 4k and b bar is equal to minus 4i plus 6j minus 8. From this b bar you can take 2 common. Therefore take 2 common. After taking minus 2 outside the bracket, in the bracket it will be 2i minus 3j plus 4k. And what is this in the bracket? That is nothing but a bar. you keep that value of a bar, and in this way b bar will be minus 2 times a bar. Means one vector is scalar multiple of other, and if one vector is scalar multiple of other, then vectors are collinear, means they are parallel to each other. Okay, write down b bar is scalar multiple of a bar, therefore b bar is parallel to a bar. If one vector is scalar multiple of other, means they are collinear to each other, means they are parallel to each other. Okay.